Good morning. This is Math Lesson 137. Today we're doing algebraic multiplication, but we're going to start off with a mental review. I know some of you really like these, but we need to get our mental muscles warmed up. Some of you don't like them. You still need to get your mental muscles warmed up. So I'm going to give you some verbal long problems. See if you can keep up. These are the ones, it's not order of operations. It just goes right in order of the ones I tell you. You're used to this. So here we go. The first one, 76 minus 4 divided by 9 times 6 minus 3 divided by 5 times 7 minus 3 divided by 5 equals. Hopefully you got 12. That was the correct answer. If you kept up and went along, that should be the correct one, number 12. All right, here we go. Again, 108 divided by 9 times 6 divided by 9 times 7 minus 7 divided by 7 times 12 minus 3 divided by 9 equals. Did you get 9? Because that was the correct answer. If not, I hope you were pretty close, but really I'm hoping that you all got 9. Let's do another one. A lot of 5s in this one. Get ready. 5 times 5 plus 5 minus 5 plus 5 times 5 divided by 5 times 5 equals. You should have kept up with that. That should have been fairly easy, and you should have arrived at 150, which you were already at earlier. Then you divided by 5 and multiply by 5 again. You're back at 150. Another one, 6 plus 5 plus 5 plus 2 divided by 3 times 4 minus 2 divided by 1. Should be 22. 22 should be the answer. Again, you're doing these mentally, not trying to write these down as I say them. Follow along in your mind. All right, last one for today. 8 times 8 plus 8 plus 8 minus 8 times 2 divided by 2 plus 2. Did you get 74? Hopefully that's what you got. That was our little brain warm-up this morning before we start the lesson. So let's do some flashcard review of some geometry terms and see if you remember when we went through these. So we're going to start with this. Hopefully you know the name is point. This one, line segment, line, extends without end in both directions. How about this one? Ray. That's an angle. Remember, these are intersecting lines. Anytime they cross, no particular form or shape, intersecting lines. Remember, these are perpendicular. They're very specific, and they form 4 perfect square corners. One perfectly vertical, one perfectly horizontal, perpendicular lines. How about these ones that never cross? Parallel lines. Same shape, not same size. There was a word for it, and it started with an S. Hopefully you remember it's similar triangles or similar figures. What about same size, same shape? We've used this word over and over throughout. Congruent shapes or congruent triangles. This shape, parallelogram, really? Do you remember this is rhombus? Trapezoid only has one set of parallel lines. Pentagon, 5 sides, pentagon. How about this one? Hopefully you remember it's a hexagon, 6 sides is a hexagon. 7-sided figure, heptagon. We don't use that as often, but we did learn the term heptagon. H-E-P-T. All right, this one we should all know. Octagon. How about the corner edge? Hopefully you remembered vertex. That's where line segments meet. Each corner is also known as a vertex. How about this one? When we're doing this on a parallelogram or a rectangle, hopefully you remember it's a diagonal. All right, let's remember and review. Sorry, I had to stretch my back there. How about the area of a triangle? Hopefully you remember A equals 1/2 times base times height. This one? A equals base times height. A equals length times width. P equals 2 times the length plus 2 times the width. Remember, those are in parentheses. A equals side squared, or side times side. P equals 4 times side, or side plus side plus side plus side. C equals pi times diameter. And A equals pi times the radius squared. Okay. We haven't been over this in a while. A square foot is how many square inches? Remember, square is anything multiplied by itself. So if we know there's 12 inches in a foot, when you're talking about square inches in a square foot, you should remember we do 12 times 12. So there's 144 square inches inside 1 square foot, just like there's 12 inches in a regular foot. So knowing that, what would this one be? Should have gotten 9, right? Because there's 3 feet in a yard, so a square yard would have to be squaring 3 times 3, and we get, yay, 9 square feet. Right, so that's our review for this morning. Let's get started with the lesson. You should have your worksheet for lesson 137, algebraic multiplication. All right, facts. Since I can't call on you to read them, you're going to have to read along as I read out loud. So algebra, it's an actual definition. This is one of your terms that you should know. It's a continuation of arithmetic. All right, basically, it's a form of math. Right? It's a branch of math that uses letters and other symbols like pi to represent unknown numbers and apply our math procedures or operations to them. Because X is a letter, we've already learned this earlier in the year, and I told you you're going to start seeing it more and more and more often throughout the math starting from this point, where we're going to stop using that X for multiplication. We've already learned that you can do it that way, or look at the example with a dot, not down where the decimal point is, but up in the middle. And you can see some examples up here already on the board as well as on your paper. We use that dot for multiplication. We also can use parentheses to show multiplication. When something is next to parentheses, like they have the 6 parentheses 3 right there in your example, that means you're going to multiply. They don't need to put a different operational symbol there. We understand it's not adding, it's not subtracting, it's not dividing. It's going to be multiplication. And of course, you could write it out in words, 6 times 3. Fact 3, a letter and a number appearing side by side also show multiplication. I can't do that with 2 numbers. So if I'm doing 6 times 3, I would never do this. That's 63. But if I was multiplying it by, let's say, a value in a formula, something like this, I could put, instead of perimeter equals 4 times S, I could put perimeter equals 4S. The number will always come in front of a letter. By the way, you would never put S4. So again, starting good habits for when we get into our pre-algebra work, because we're already working with algebraic multiplication today. 4S. So a letter and a number. They also gave us pi times the radius squared, which I have up here. So if we were to write that using algebraic multiplication, I can take out that times so that it doesn't look like an X when I'm starting to add letters, and X is used a lot. So we'll just put it right next to each other. pi radius squared. I can put the symbol and the number, or symbol and the letter, sorry, together, and that's still going to show me that I'm multiplying these two. I'm not adding, subtracting, or dividing. So if we were going to simplify this using algebraic multiplication, we can actually get rid of those parentheses. It's still the formula for perimeter, but instead of 2 times the length written this way, 2 times L, still going to represent 2 times the length, plus, this only works for multiplication. We never put letters or numbers together for addition, subtraction, or division, only multiplication. So I need to show that there's an addition operation here. And then 2 times W, 2W. So it's just a new way of writing the same operations, but showing that we recognize this is how in algebra we demonstrate the operation of multiplication. We can use the X, but the more you use algebra, the fewer times you're going to see that X used for multiplying. We often use the dot, or we'll put things together, or we could use parentheses. No other operation symbols in between these, so that's going to demonstrate multiplication. So looking at your formulas in section 1, 1A, how could you write pi times diameter using algebraic multiplication? Well, we could switch that formula and write it this way. So in the blank for 1A, C equals pi times diameter is written this way. Number 2, A equals base times height. You should know that's for a parallelogram. And hopefully, you didn't even need my help to understand that we're going to rewrite it this way. A equals base times height. It just looks a little different. Then we've got C. Gee, that looks awfully familiar. And then D also can be expressed using algebraic multiplication. 1/2, because that's a number. I can put it right in front of a letter, and I can put the other letter right next to it. 1/2 times the base times the height can be represented without any multiplication symbol in between, because it's recognized within algebra, letters together and numbers with letters together is automatically referring to multiplication. All right, so that's just an introduction. Should be easy. It's just introducing a new way of looking at things, so when we get into equations, this isn't going to throw you off because you'll already have seen it. So let's review what we did yesterday with order of operations. Remember the word, or the silly sentence if you want. We had P for parentheses, E for exponents, MD, multiplication and division, and last but not least, AS for addition and subtraction. And purple eggplants do make disgusting afternoon snacks, right? Or PEMDAS. So let's use this order again to do section 2. Go ahead and I want you to try them on your own. Pause this while you work on them, and then we'll go over the directions together for the answers. All right, so hopefully you completed section 2, A through E. Let's go over and see how well you did. If you made a mistake, erase and fill it in the correct way as I go through the answers, making sure you've got this down and that you showed your work the way I expect you to. All right, so your first thing here should have been to recognize no parentheses, no exponents, but there's multiplication. So 2 times 3, we rewrite it just to form good habits, not because I think you can't remember that it's 2 plus 6, but when we get into those longer problems, having those good habits is going to be super important. So you should have gotten the answer 8, but your work should be demonstrated out this way so I can see each time how you got your answer. Here, we do have no parentheses. I know I'm skipping to C, and I think you can hang with me. All right, no parentheses, but we have exponents. So 2 to the power of 2 is going to be 4. Next, I go to my multiplication step. That's all that's left. So for C, your answer should be 28. Let's go back to B. We've already learned that a fraction is another way of showing division. We've simplified improper fractions for a couple years now. So 15 over 3 times 6 is this step, but we're going from left to right. So hopefully you remembered your division gets done first because it becomes first on the left, then we can multiply across. These are a paired deal. So 15 divided by 3, we get 5. Now we can move across and do that 5 times 6. So your answer should be 30. And this is where, if you've made any mistakes or errors in the order of the steps, you can see why it's important to have an order so that we're not getting multiple answers. We have one very clear answer. No parentheses, no exponents, and they happen to already have the multiplication first. So for problem D, 5 times 6, and it should have been a very easy 33 on this one. This one, hopefully you didn't struggle with. We have parentheses, but there's nothing inside of it to do. So really what it's indicating is that it was an exponent problem, E for exponents, and it's showing it's not just 3 squared, it's the whole fraction. So we do 3 squared, 3 times 3, and 4 squared, 4 times 4. Then what we're left with, sorry I didn't underline it, is the remainder of your fraction problem. Common denominators, we never do 16 plus 16. I hope your brains aren't that rusty. And 9 plus 3 is 12, so we get 12 sixteenths. And of course, we always simplify. We can divide them both by 4. And we're down to 3/4. So 3/4 squared, 9 sixteenths, plus 3 sixteenths gives us 12 sixteenths. We can reduce it by 4s, and we get 3/4. Any questions? All right, we've gone over formulas. Yes? Hold on a second. Sorry, had to pause for a second as someone called in and needed an answer to a question, so let's pick up where we left off. So we've done section 1 and 2 together. Section 3 you should be able to figure out on your own because we've gone over those formulas. We just reviewed them at the beginning. We also reviewed them yesterday. Hopefully you wrote them down. Notice you're finding the areas, but I want you to recognize the second part of those directions. Write the formula without using the symbol. So like we've changed these, anytime you see these formulas here in section 3, start off with your first part being this, then solve through and find the answer. Of course, area is always in square units, so whether it's square inches, square meters, square centimeters, please make sure you're doing that. On the back, I want you to cross out number 4 and I want you to cross out number 5. We have not done those. Those are part of those skipped lessons. So cross those 2 numbers out completely. Don't forget number 6, you are solving, dividing with decimals, round to the nearest tenth. How many decimal places then will you have in your answer? 1, right? Tenth is 1. So you're going to have to divide out to 2 places so that it will indicate to you, do you need to keep the tenths place as it is or bump it up? So please work carefully. Number 7, you're just matching the definition with the parts, either of the circle or the tool or of the formula, so matching it with the definition. And then number 8, it gives us a percentage problem where we actually have to find the percent. So let's review that very quickly. How do we find percent? Like 8A. Now these are not the numbers used in 8A. This is just a sample reminder. So let's say we have 12 out of 60 students own a pet bird. I just went with something random. What percent of students own a pet bird? Remember, we take the small amount and we put it over the total. As we simplify that fraction, when we get down to simplest form, it either should be one we're already familiar with and have memorized, which we know 1/5 is 0.2. We know we convert 0.2 to 20%. If it's not a fraction we've memorized and recognized, of course we divide it, putting the top number in the box and the bottom number outside. We get a decimal answer, which we have to convert to percent. Okay, but we start out with a fraction, smaller amount, over the total to find the percent, and that's just going to be like in 8A, but not these numbers, obviously. Okay. All right, so 8A, finding that percent. B, it gives you the percent, it gives you the total. Find the percentage. We reviewed that yesterday. C is a lot of words for something that's really not a complex problem. It says the amount of sugar a rectangular box holds in cubic inches, because now we're not talking about just filling up with squares, a flat shape. We're talking about a 3D object. Let me grab one here. There we go, like a 3D object. It's not only got a length and a width, it's also got a depth, or we call it a length, width, and height. So this would be cubic inches. It would be like cutting it up in cubes. How many cubes would fit in it? So they're talking about the cereal box, and they want to know, using the formula V equals LWH, what is the cubic inches, or the number of cubic inches that the box holds? Now remember, when we've got a formula, like this, we just learned today that this represents multiplication. They give us a length measurement, they give us a width measurement, they give us a height measurement. That is our answer. And volume is always measured, once you multiply, it's in cubic units. Let's say, for example, this one is in inches. We can do cubic inches, or if you remember, we learned that the third power is also called cubed. So for those of you that like using the exponent 2 for our square inches, here's your cubic inches for volume. So they want you to be able to recognize how this formula works and plug in the information. And then D, we haven't done in a long time. It says David Blackburn received a commission of $50. So that's what he got off the sales. And then it says his rate is 5%. How much were his sales? We're not doing 5% of 50. We're finding what the big amount was that he sold. So this, I wanted to go over how we're going to set it up, and I did use the actual numbers. So for 8D, finding the total sales, we already know that sales times the percent equals our commission. So the reverse also has to be true. Commission divided by percent is going to get us our sales. Okay. Well, our commission was $50. All right, so in this problem, he earned $50 commission based on his sales. His percent rate was 5%. So of course, we change it to a decimal. We don't do 50 divided by 5. It's a percentage, so 0.05. So we've got our percent as a decimal. Our commission in here, $50 divided by 0.05, which is 5%, is going to result in our sales. And of course, we need the dollar sign in our answer. And I even put the little green carrots here to remind you when we are dividing by a decimal, we got to knock it over 2 spaces, or however many spaces are here in our divisor, because we cannot keep it there, or our decimal is going to be in the wrong place in our answer. So you might want to remember that for number 6 as well when you're dividing with decimals. All right, so commission divided by your percentage as a decimal equals your sales. And that should cover you for today's math unit. And I will see you on Monday with the next math lesson. So I hope this is helpful, and I will talk to you then. Thanks. Bye.